Do you want to go on a celestial poltergeist or an expedition to the axis of evil? Like something loud and deadly, but it's unlikely that any of our space travelers will turn back in fear. We are willing to overcome any difficulties to learn more about the universe. In fact, Poltergeist is the name of planet PSRB 1257, 12C, 2,300 light-years from the Sun in the constellation Virgo. He has only the conditions of hell. A poltergeist is showering deadly ions from a nearby star, a pulsar. But there are no otherworldly powers, and the axis of evil is the direction in which galaxies and large space objects are aligned. If such a structure were confirmed to exist, it would disrupt the standard model of cosmology. This shows that space has no definite direction. However, there is no danger to space travelers. Instead, we suggest going to the edge of the universe, a world full of truly unexplored and insane mysteries. It will be a real space odyssey. Along the way, we encounter a deadly labyrinth from which we cannot escape, admire a beautiful butterfly, and cross the territory of strange cosmic threads that cause storms. But what awaits us in the finale? Are we going to run into some obscure wall? Will we face an evil force that destroys everything around us? Or will we see other amazing worlds? Anything is possible outside the universe. But before we set out, let us know how the edge of the world has been searched at different times. The starlit sky has fascinated people since ancient times. Our distant ancestors were eager to know what its shining fabric was made of, what form it took, and where it ended up. Answers were sought in relation to the earthly and familiar. The firm was often imagined as a carpet, decorated with stones or even a beautiful flower. The Egyptians, for example, believed that it was a lotus. Its essence is the center of the world where the gods live, and the world in the leaves is where people live. Hindu texts describe space as an egg, Dravetic, like an island floating in the endless void. Over time, more was learned about space, and perceptions changed. In 1610, Galileo Galilei pointed his first telescope at the sky. A famous astronomer discovered a cluster of countless stars. It is hidden in a band of light called the Milky Way. Then the outer space for humans increased infinitely. A century and a half later, in 1784 to 1785, William Herschel first attempted to determine the size and shape of our galaxy. The scientist concluded that the path of the Milky Way resembles a flat disk, but did not greatly estimate its diameter. Another century and a half later, when astronomers built powerful enough telescopes, the frontiers of space were pushed back for us. In 1924 to 1925, Edwin Hubble proved that the universe is not limited to our galaxy. The Milky Way turns out to be just one of many concentrations of stars, dust, and debris. Then came a new generation of advanced telescopes. Astronomers have seen with their help that the visible universe extends to incredible distances. There are about 2 trillion galaxies. Scientists have determined the age of the universe, otherwise known as the cosmic light horizon, or megalax. That's about 13.8 billion years. This is when light particles, photons, reach the Earth. According to American astrophysicist John Mutter, it is impossible to keep up with the age of the universe. When we look into deep space, we look back and see the distant regions of the universe, what they were a long time ago. Why can't we look back? The universe, according to the accepted theory, came into existence as a result of the Big Bang. The material exploded in diversity with unimaginable force and has been expanding ever since. During the very hot period before the galaxy formed, it was filled with hot, glowing gas and was therefore opaque. During the first million years after the Big Bang, as space expanded, the gas cooled to 10,000 degrees Celsius and glowed. This glow was originally ultraviolet, but as the universe expanded, it shifted to longer wavelengths. So today we observe it in microwave and infrared radiation coming from the edge of the metagalaxy. You can think of the source of the microwave background as a distant spherical wall. It limits the visible universe. We can't look at this wall yet. However, astronomers study the farthest reaches of the universe. They have shown us what awaits us on the way to the outer reaches of the visible universe. Of course, the positions of the celestial bodies observed by astronomers today have changed. The universe is expanding faster than the speed of light, and it is impossible to outrun it. Even the superfast stars of the future won't be able to. When flying through space, these things don't stop moving either. We do not know them. But let's imagine they found a way to travel fast through space. Well, for example, with a ready-to-go container that compresses space or compresses the structure of molecules. We can even determine our route in advance using a special map by Johns Hopkins University astronomers in the United States. This guide shows the positions of 200,000 galaxies stretching from our Milky Way to the farthest reaches of space. The data comes from observations from the Apache Point Telescope in New Mexico. Observatories have been probing various parts of space since 2000, allowing scientists to create the most complete maps of the observable universe. A map of U.S. scientists is a credential that looks like a slice of pizza. It provides the most accurate visualization of galaxies from the Milky Way to the edge of space. If the pointer to our coordinates were placed on the map, it would be placed at the sharp end of the 10-degree circle. It is part of the great circle around our galaxy, which in turn is a piece of the unimaginably large universe. According to scientists, from the beginning, the mug was 13.7 billion light-years. Starting at its lower edge, the blue shows spiral galaxies 2 billion light-years away. The yellow dots are elliptical galaxies that are much brighter. The large red portion of the map also marks elliptical galaxies, but 4 to 8 billion light-years from Earth. Blue indicates quasars. Then comes a billion light-years of total darkness, a line that shows the edge of the visible universe at the end. This relic is a field of light, the light left over from the Big Bang solar system. We set out with the map. At the edge of the solar system lies the precious cloud. There have been no direct observations of this structure, but circumstantial evidence proves its existence. The charge cloud is thought to consist of two distinct regions, a spherical outer region and a disc-shaped inner region. They consist mostly of water, ammonia, and methane ice rocks. Astronomers believe that these objects formed in the early stages of the development of the planetary system near the Sun. Later, the giant planets hurled them into space with the force of gravity. We also have to maneuver among the trillions of long-period comets that are filled with precious clouds. After leaving it, we reach the boundary of the interstellar medium, where the heliosphere is located. This unique shell of the solar system, filled with plasma from the solar wind, orbits the star faster than the speed of sound. It is about 17.5 billion kilometers from the Sun. That is, twice as far as Pluto. So far, only the Voyager 1 and Voyager 2 probes have reached it. Retracing their tracks, our expedition may encounter strange and still unexplained phenomena. Scientists from Princeton University in the United States have discovered amazing structures and powerful waves in the space between the solar system and interstellar space. Data from the IBEX satellite show that a storm can rage over an area of about 1.5 billion kilometers. We will reach the edge of the solar system and see our world from the outside. What will it look like? To this day, Astronomers believe that the solar system is like a long-tailed comet flying through space. The heliosphere is the large plume that stretches behind the star system as it orbits the galactic center. But recent models have suggested that the solar system may resemble a crescent-shaped bridge on the outskirts of the solar system. After the storms in the heliosphere, the calm interstellar space of the Milky Way awaits us. Or is it turbulent there, too? The further away from the galactic center, the more densely populated region of new luminaries, dwarfs, stars, and planets there will be. But they are also found on the edge of the Straw Road. The most unlikely star in the outer regions of the galaxy is WB 89-789. It was recently discovered by Japanese and Taiwanese astronomers. This newborn luminary is 62,000 light-years from the center of the Milky Way. Our Sun, by comparison, is twice as close to the galactic center. After the investigation, the protostars surprised the scientists. Observations made by the ALMA telescope in Chile show that the young luminaries are surrounded by an unprecedented variety of molecules. They contain carbon, oxygen, nitrogen, sulfur, and silicon. They also include complex organic compounds with up to 9 atoms: methanol, ethanol, methyl formate, and others. They serve as raw materials for the larger molecules necessary for the formation of life. Who knows what fantastical creatures we might encounter in the WB 89-789 system? But what lies at the far end of the galaxy? Scientists say it is far from a desert region. Outside the galactic disk, the Gaia Space Observatory says, there are many large unseen structures. They look like some sort of large spinneret fibers. The authors of the study believe that they are remnants of the outer arms of the Milky Way. At various times, they were destroyed by galactic satellites, and now they themselves are destroying the environment. But fuzzy filaments may be far from the edge of the Milky Way, and not the most dangerous place on its periphery. A new study of 200 variable stars has revealed the outer limits of our galaxy. According to theoretical calculations, its edge was several tens of thousands of light-years from the center. So we're almost on a collision course with neighboring Andromeda. There is almost no space between galaxies. In this region, we can expect dangerous areas of turbulence, such as red-hot plasma, or something more unexpected. Once out of such a turbulent zone, it doesn't matter which way we fly. The standard model of cosmology holds that space has no definite direction. This is not a small area, but a huge area, hundreds of billions of kilometers in size. If you could see such a large piece of sky from Earth, say, from the planet Proxima in the constellation Alpha Centauri, the picture would not change appreciably. So we can go either way, from galaxy to galaxy, past universes, planets, stars, interstellar and intergalactic space, dark, empty, and cold. We may encounter some hellish places along the way. It is better to avoid them in order to avoid getting burned. These are primarily black holes, which are often referred to as real space monsters. They attract with their own gravity and can absorb any matter that comes their way. Fortunately, large objects are surrounded by bright accretion disks of red-hot plasma. Most recently, the supermassive black hole at the center of our Milky Way, the star A, is Sagittarius. Isn't it easy to find such a bright sign created by nature in space? And, of course, stay away. A bit tricky. This is essentially the space between the galactic filaments where the galaxies themselves do not exist. The largest of these are called superwoods. But what kind of danger could the voids of heaven pose? Let's take the large supervoid of Eridanus. This cosmic anomaly is incredibly distant, 60 billion light-years from Earth, in the constellation Eridanus. The supervoid is a fantastic size, 1.8 billion light-years across, almost to the edge of the visible universe. Compared to that, the Milky Way seems like a tiny invisible dot on the map. Its size is estimated to be only 100,000 light-years. So, supervoids could contain 18,000 galaxies like ours. A supervacuum is characterized by an unusually low microwave background. It is also very cold, a lower temperature than relic radiation. For this reason, astronomers have called the void a relic cold spot. Scientists believe that it formed at the end of the Big Bang, when the hot universe began to cool dramatically. This process can be compared to the appearance of air bubbles in ice. Generally, there is nothing in the supermassive universe that is believed to be filled with dark energy. This does not contradict the standard model of cosmology. If our first starship fell into the Eridanus supervoid, it would be the ultimate death trap. Relic cold is known as the darkest place in the universe. There are no stars or galaxies. Not one of its rays illuminates its infinite depths. Nothing can be seen, heard, or felt in such a place. Even with the coolest GPS, we won't be able to find our way out of infinite nothingness. We won't be going to amazing places like the supernovas, but we'll certainly be flying closer to the dome, whose brilliant glow, despite the great distances astronomers observe Earth from. The most impressive is considered to be the Butterfly Nebula, or NGC 6302, in the constellation Scorpius. It is 2,500 to 3,800 light-years from Earth. Nebula's butterfly appearance is given by the dying stars at its core, which have spewed huge plumes of gas into space as they agonized. This gas, heated up to 20,000 degrees, passes through space at a speed of 100,000 kilometers per hour. But symbolizing the beauty of the universe is the architecture in the Eagle Nebula, known as the Pillars of Creation. The fantastic pillars of the sky seem to be the creation of higher forces. In fact, they are filled with the same clouds of gas and dust that nature weaves with special skill. Their strange silhouettes are illuminated by intense ultraviolet light from the young, massive stars that cluster around them. Meanwhile, the cocoons inside the columns form new stars. But the real secret of the universe is revealed to us by the bright light of the Bell Nebula, which seems to be placed in the galaxy cluster C10024. 17. The nebula is thought to have formed during the collision of two giant titans, galactic masses. In a catastrophe, such giant clusters cannot be held together by the weight of their stars. They are probably held together by dark matter that forms a ring. Dark matter in general, composed of elementary particles, is still unknown to science. But distant galaxies in the C-100,024+17 cluster illuminated the cloud with their radiation. This celestial jewel is beyond the visible universe. You would have to travel 5 billion light-years to see it. Earendel, or the morning star, is even farther from Earth. He was indeed born at the dawn of the universe. The light that astronomers detected was emitted by a star 900 million years after the Big Bang. It is twice as hot as the Sun and 1,000,000 times brighter. Earendel has a mass of 50 to 100 times that of the Sun, and its surface temperature is estimated to be at least 20,000 Kelvin. The James Webb Space Telescope recently captured the most detailed image of Earendel yet. Above it, the star shines blue-white. It will be an unforgettable sight, but no one is going to see it for real. Even if by some miracle we were to drive Earendel while watching the video, we couldn't find anything in her place. The star died a long time ago. Such hot and bright stars usually don't last very long. They quickly burn up their hydrogen reserves, becoming supergiants and then supernovae. With the morning star, this may have been long ago, and its light, like an immortal avatar, still travels through space. We will go to another object in the outer universe, which will live for a very long time. This quasar J0313-1806 was discovered by astronomers at the University of Arizona in the United States. This was when the universe existed 670 million years ago. As we approach this space region, we will be amazed by the numerous celestial fireworks. First, the quasar itself is incredibly bright. It contains a supermassive black hole with 1.6 billion solar masses that emits giant streams of plasma, jets, and fuel. For astrophysicists, J0313-1806 is a rare find. Only two very distant quasars are known today. With their help, scientists want to test the theory of the formation of supermassive black holes in the early universe, as well as estimate their growth rates. In addition, J0313-1806 is the center of a galaxy that is shining stars with unprecedented activity. The birth rate of light is 200 solar masses per year. If you compare this to the rate of star formation in the Milky Way, in our galaxy it is equal to 3 solar masses per year. However, this is not a record in space. Galaxy Mamba 9 contains a large amount of dust and gas that prints out the stars one by one, like on a printer. The total mass of light produced in 1 year is more than 1,000 times the mass of the Sun. Mamba 9 was recently considered the most distant of the galaxies. According to research, it was formed 970 million years after the Big Bang. The distance from Mamba 9 to our solar system is 13 billion light-years. But now, this multi-star kindergarten has lost its record-breaking title. The I-galaxy Z13, discovered by astronomers with the James Webb Telescope, is 13.5 billion light-years from Earth. It was formed over 300 million years after the Big Bang. It's actually a space dinosaur, with a mass roughly equivalent to 1 billion solar masses. It is about 1,600 light-years across. True, from the outside, the galaxy does not look like a terrible lizard. When James Webb interpreted the telescope image from visible infrared light, the eye of Z13 looked like a stunning red flower with a white center. But is there anything else? It could happen. It would be a shiny wall. But you should not be upset, because the wall will not be able to block the way of our expedition. If you look closely, each bright spot in this amazing structure is a different galaxy. There are over 100,000 of them in this region. Scientists have calculated that the object has a quadrillion, that is 15 zero stars like our Sun. The Megagiant structure is called the South Pole Wall and is 500 million light-years from Earth. The wall is astonishing in its size, even on a cosmic scale. It spans 1.4 billion light-years in space. For comparison, the size of the Milky Way is about 100,000 light-years. By measuring the redshift of the galaxies, scientists were able to detect the Great Wall. We know that everything in the universe is in motion. As they do so, their light waves are stretched, changing the light. By evaluating this shift in light, it is possible to understand what an object is and how it moves through space. Thus, scientists have found other similar objects. Compared to one of these, the South Pole Wall will seem like a short fence. The Great Wall of Hercules, the Northern Corona, a large flat structure of galaxies stretching 10 billion light-years into space. It makes up 10% of the entire observable universe and probably stretches to the end. So we've reached the edge of the metagalaxy for astronomical observations. We already know that it is 13.8 billion light-years. Here's how long it takes photons from the universe to reach Earth. But in the meantime, the universe continues to expand, and the object carrying the photons' information is being pushed into the distance by the expansion of space. The universe is thought to be 92 to 94 billion light-years in diameter from Earth to the cosmic light horizon for all time since its birth. This will be the edge of our universe. It can really be compared to a wall. There is darkness behind it because the relic radiation does not travel there. Does this mean that there is nothing in the observable universe? Could there be large galaxies, stars, and planets out there that are invisible to us? Or is there something more exotic, even terrifying? And is our expedition in danger of disappearing into the abyss of darkness? What are you thinking about? A. Is there any possibility of becoming nothing in the full sense of the word outside the universe? It's not a very pleasant prospect, but scientists allow this possibility. Based on this observation, galaxies are dying en masse in space. The Department of Astrophysicists of the International Center for Radio Astronomy Research said this after studying more than 11,000 objects. Researchers have come up with interesting theories to explain such a large-scale disease. One of them links the extinction of galaxies to vacuum decay. We now live in a world with stable energy levels. Scientists called this state a false vacuum and compared it to equilibrium. They suggest that one day, due to some shock or other event, such an equilibrium will appear as an energy depression. As a result, the energy level in the universe will drop to a minimum. Then the false vacuum begins to dissipate, giving way to the true vacuum. Perhaps this process is set in motion, and the vacuum eats galaxies at the edge of the universe. It is true that galaxies decay slowly, and vacuum decay should, according to physical laws, occur at the speed of light. It would destroy the Earth in seconds. Thus, our expedition is not threatened by a complete vacuum. By the way, you don't have to worry about the Earth anyway. Even if vacuum decay has begun at the edge of the universe, it will not reach us for billions of years. But suddenly, instead, we were caught in a vortex of crazy energy. According to one of the hypotheses, the galaxies can spread the most mysterious forces of the universe, the dark stream, the coordinated movement of galaxy clusters into an unknown mass in the invisible region of the universe. Scientists at the Goddard Space Flight Center, NASA, discovered these signs of the phenomenon. The theory was proposed based on the analysis of data from the WMAP survey in more than 1,000 clusters. This is a very large-scale study that covers a significant portion of the observable universe. The authors of the paper said that the dark stream stretches for 2.5 billion light-years. It rushes towards the supercluster of large galaxies, then towards the stars Centauri and Hydra. Scientists believe that this insane amount of snow could pull the entire universe into a black hole of unimaginable size. When the monster density reaches a critical point, a big bang will occur, and a new universe will be born. According to another, more exotic version, the black stream was formed as a result of the gravitational pull of some mass from a parallel universe. However, so far, these dire hypotheses have been largely unsupported. However, there are anomalies beyond the visible universe that alarm astrophysicists. Recent observations have shown that some astronomical objects do not move as they should. Hence, there may be unknown massive structures outside the metagalaxy. Their attraction affects the objects around them. Scientists call such hypothetical structures extra-metagalactic. Unfortunately, scientific methods to accurately determine their nature are still not available. The existence of such objects suggests that the universe may continue beyond the visible part of it, not just at its edge. Scientists say The answer depends largely on the shape of the universe. Theoretically, there are three main options, each of which is characterized by the degree of curvature of the external space. In turn, curvature is related to the mass of the universe. If we take individual parts of the sky, very large objects can affect the fabric of space and the energy of its expansion. Scientists know of examples of supermassive black holes destroying everything around them. How does this affect the universe at large? The actual density of space may exceed the critical density. That is, the mass is sufficient to stop the expansion of space, and it will spread uniformly. In such a model, the universe is closed and finite, although not precisely defined. To understand this better, imagine two parallel straight lines on a wide surface. The lines will not be parallel to each other forever and will certainly intersect. An example of this is the meridians, which cross the equator at right angles and will remain parallel at that point, but at the poles they intersect. Moving in one direction, our spaceship will return to where we left off. However, in the case of the universe, a complete analogy with the Earth is still inconsistent. Let's not forget the expansion of space. Scientists see galaxies moving away. This happens when viewed from any point in space in all directions. They move at the same speed everywhere. But the farther from the observer, the faster. For example, you are looking through a telescope, of course, from our Milky Way. You see Galaxy B moving away from you at a distance of 16,000 kilometers per second. But if some hypothetical alien from Galaxy B looks through his alien telescope, he sees our galaxy flying away from A. For an alien, it travels at 16,000 kilometers per second, and vice versa. Meanwhile, an alien race from Galaxy C is located in the same direction as B, but twice as far from Earth. From point C, the alien will see Galaxy B traveling at 16,000 kilometers per second. Our distant Galaxy A is traveling at 32,000 kilometers per second. You will see that Galaxy C is accelerating at a similar speed, 32,000 kilometers per second. So everyone will have a different point that produces the same results. Thus, a spherical universe can probably be compared to a helium balloon inflating and expanding in all directions. On the larger scales of the universe, the process is faster than the speed of light. According to this model, we will never be able to fly through space, complete the cycle, and return to the starting point. At the same time, scientists believe that another flat shape of the universe is more promising. This is possible if the mass of the universe is approximately equal to the critical mass. Then its expansion slows down to infinity. Einstein called this model an infinite but not bounded universe. A flat universe is consistent with observation and theory, so this idea is at the heart of modern cosmology. A time when data from orbital observatories were confirmed to study relic radiation. They showed that space is completely non-linear. The universe is as flat as a large sheet of paper, at least within the limits of astronomical measurements. So, in a new study, an international team of scientists shows that relic radiation has caused significant temperature changes over billions of years. Astrophysicists calculated the predicted amount of change and compared it with what they actually observed. If the data is inconsistent, the parallel lines of light rays have changed direction over time. Then the universe would bend its shape. In the end, they found small inconsistencies in the models, namely small shifts in the relic rays. The culprits are probably supermassive voids, where the density of galaxies is thousands of times less than the average of the universe. In contrast, superclusters such as the Big Dipper and a Shepley are so packed with celestial bodies that other galaxies begin to orbit them. To us, such things seem endless. However, they are very small in spatial scale. In large regions, for example, 200 million light-years away, the matter in the universe remains homogeneous in all respects. The situation is similar with the curved area. According to American astrophysicist David Spergel, the universe has flattened out due to rapid expansion. We know that in the beginning the universe was a ball of energy exploding at incredible speeds over vast distances. This process resulted in the area being flat, or very close to it. We can fly around the flat, expand the universe as we please, and everything around us will not change. We will not reach the edge. We are going to find more galaxies, stars, galaxies, and black holes. Endless. Meanwhile, monitoring the relic's radiation revealed some strange, unexplained anomalies, like large structures that shouldn't be there. Then there are the inexplicable patterns in the light of the Big Bang. According to an international team of astrophysicists, all this can be explained if the universe is like a simple donut. A recent study revealed that the unusual nature of the relic radiation in March 2023 is due to the complex shape of the universe. It's flat, but it doesn't look like a piece of paper. Airplanes are different. For example, if you draw parallel lines on a piece of paper and then rotate it, you get a cylinder. All the lines there would remain parallel. The cylinder will remain geometrically flat. Only its spatial characteristics will change. If you join the edges of this cylinder together, you get a shape like a donut. Or here is another version of the complex flat form. Take a thin strip of paper, turn one part of the strip 180 degrees, and connect its edges. As a result, you will get a Mobius strip. This object is also geometrically flat because parallel lines do not intersect. In total, there are 18 geometric flat three-dimensional objects with different spatial shapes. A more complex universe than a simple flat one could explain the anomalies in the relic radiation. To do this, scientists say, it needs to be like a donut, not a stomach. If we travel through such a circular space, we will have a fantastic experience. Far away, scientists believe, we can see a copy of ourselves, much younger. For example, let's take a universe theorized to be 1 billion light-years in diameter. In this case, astronomers will observe the Milky Way galaxy as it was 1 billion years ago, then another copy created 2 billion years ago, and so on. And the copy may be deliberately reversed. But if the density of the universe is too low, there will be no spheres, no planes, no donuts. Then, the weight of matter will no longer be able to hold back the expansion of space, and the universe will bend into a saddle shape. But is such a scenario even possible? The curved shape contradicts an accepted principle in cosmology that the universe grew to enormous size moments after the Big Bang. At the same time, observations of the WMAP microwave zone provide a basis for viewing a version of the curved space. They showed that hot and cold spots on one side of space are at higher or lower temperatures than the other. That is, the universe may indeed be saddle-shaped. Planck satellite data recently confirmed this hypothesis. What does a boy-shaped universe look like to scientists? There, any object that appears to be moving parallel to another object is actually moving away from it. Therefore, light rays travel in curved paths. In particular, they follow the lines that make up the shortest distance in the curve width. This is how airplanes follow great circles as they fly around the Earth. Astrophysicists say that the universe was bent by some catastrophic impact or other major catastrophe. For example, our universe could collide with another universe, but this theory is now considered by most cosmologists to be less plausible than the earlier theory. So, can we finally settle on a flat universe? Indeed, the WMAP microwave anisotropic zone recently made new measurements of the microwave background variations. The apparatus tried to determine whether the universe was open or closed. The result is flat. The error is only 0.4%, which is definitely very small, but they leave doubt. How to distribute them? In the near future, astronomers will not be able to see our universe beyond the metagalaxy. However, scientists are trying to do this with theoretical calculations and modeling. For example, the Standard Model of Physics helped predict many particles, in particular the Higgs boson, long before its discovery. Physicists thought that such particles existed, and this helped to discover the breast. In time, the theoretical study of the universe may also yield results. Other than that, it's absolutely fantastic. Now, imagine a version where outside the universe there is no time and no space, where the usual physical laws stop working. And concepts such as matter, and energy did not exist at all. A logical extension of this was the hypothesis that our universe is part of some mega-scale cosmic structure. It is probably located in multidimensional space, and our universe, which appears to be very large, actually appears small, even partially reflected in this structure. The idea of a multiverse resonates closely with this theory, which is similar to a multiverse bubble. They are separated by thin sections that cannot be overcome. Or maybe, but only under certain conditions. According to this hypothesis, our universe began as a bridge within a larger parent meta-universe. Its birth may involve changes in the bridge wall, which have been identified as large-scale perturbations of space. One of the results may be an anomaly in the cosmic microwave background seen by the WMAP and Plan C observatories. Thus, there are several universes, and each of them is a separate place with its own physical laws. Perhaps there are strange forces and principles at work there. If we reach them, we can never understand them. Or, alternatively, it can be very simple to do. Of course, the scale of the universe is amazing. Its edge is like an unimaginable distance, and it may not happen at all. Therefore, it is not yet known whether there will be an end to our space travel. However, we will continue to reach the edge of the universe using the new theoretical calculations and observations of scientists. Thus, a unique EMI research center was established in South Korea, which will study the secrets of the universe. It is located at a depth of 1,100 meters under Mount EMI. The area of the center is 3,000 square meters, where more than 10 experiments can be conducted simultaneously. An underground facility will allow researchers to detect signatures of specific materials, objects, or structures. In this case, the underground will not interfere with background noise or external radiation. In addition, scientists hope to study the microwave background anomaly using ground-based telescopes. Any discrepancy in the expected parameters can provide valuable information about the shape of the entire universe and its edge presence. Step by step, we continue to move towards the limits of the universe. That means even more amazing space adventures lie ahead.